Yeah, some people in YouTube. Yeah.
Sage is live.
Yeah, now I can see it.
Still have 1.5 minutes to go. Wow, it doesn't. All right, let's start then.
Yeah, people will take time to. There are people in YouTube. There are some people in YouTube, but we can we can wait some more minutes.
We wait how long? 1 minute, 2?
2, 1. Yeah, this is Spain. You have to come here and you will. we had lunch just 1 hour ago.
Ah, okay, right.
Okay. Yeah. Okay.
When do you
People are
wake up?
joining.
I mean, you have to wake up for our stand-up, right? It's probably very hard
Yeah.
for you. I haven't seen you today, by the way.
Yeah, today I was not sleeping. I I have to wake up because of the kid. If not, I don't know. Yeah, I would prefer to work during the night till 2 a.m. or something like that and start to work at 10, 11.
Yeah, okay.
From So you didn't get corona, no? Finally.
No. It's actually quite useful because then I can travel. When I come back to Norway and I've been kind of infected and recovered, then I don't need to go to quarantine.
Mm.
All right, 2 minutes passed. Let's start. So I will share my screen. You see it, right?
Yes, perfect.
And now as well?
Mm-hmm. Yeah, full screen.
All right, so of course, I just need to make a disclaimer. Some of you might find it a bit boring what I'm going to go through. Some of you, if it's new, you might find it interesting. So we will have some time spent on going through the basics of event sourcing, maybe some CQRS reporting models and stuff like that. And afterwards, we will switch to Q&A. And basically, Q&A is, I expect it to be interesting. So please do participate. Please ask questions. You can start submitting questions when you feel for it. So basically, we have Q&A open, right, Paul? You see it?
Yeah, it's open. Yeah.
Yeah, so you can submit questions. Then if you want to talk, just raise your hands afterwards. When we switch to Q&A, we put you online. You can ask questions real time. So let's just then move on. Brief introduction to event sourcing. Okay, I need to tell a couple of words about myself. Otherwise, what's the point? My name is Alexey, as you probably know from the webinar announcement. I write software since I was like 15 years old, and it would be 30 years then. Quite a long time. Then I started doing domain-driven design, or learning about domain-driven design, some years ago, and I got a great interest in this field. Eventually, I learned about event sourcing, met Greg, went to conferences, at some point started speaking myself, and well, started to do it in real life systems, made many mistakes, seen people cursing event sourcing after making the same mistakes I made. But after I made mistakes, I admitted that basically the source of those things were usually my lack of understanding and lack of knowledge and skill on applying the pattern. And I decided to pursue and basically understand how it needs to work in order to, because I understood the potential of the pattern. And then at some years, I got quite proficient in implementing event source systems. And nowadays, I find it hard to find a domain where actually there is any business involved, where it's not just the storage of static data, but there is some behavior where I don't really want to apply event sourcing. So it's my preferred choice of building business software or customer-facing software, so to say. I previously worked in consulting and mainly wrote software for internal purposes of the business, although it could have been large scale, like in Philips was like internal software reaching out for 150,000 people, which is pretty decent. But then I started to work in product companies, which I find much more interesting because there's a variety of customers of different backgrounds, a different experience, different expectations, and that's, I find, a drastically different experience overall, and that's where event sourcing also applies very well in many situations. So now I work as chief architect in a company called ABAX in Norway, where we do the vehicle tracking, and there's a very interesting domain because there's a lot of event-driven operations which are not really event sourcing. There are a lot of event source systems that we have, not a lot, but quite a few. I also started working as developer advocate at Event Store, which is the company behind Event Store DB, where initially started by Greg Young many years ago. So I think my experience being a user of Event Store DB helps the company to understand the needs of developers and find things to improve and be more friendly to developers. So that's where I am today. And let's start with the talk. So we all know state-based persistence. So state-based persistence is backed up by traditional databases. Will it be relation databases? Many of you have experience with that. And document databases, where for some are new. For me, I worked with document databases before I started working with relation databases. So That's why probably eventual consistency doesn't scare me that much. So in state-based persistence, things change. So you have a state of your business object, an entity, like in this case, I use the example of an order, which everyone is familiar with. And then all of a sudden things change. So in this example, we see that the total amount of order changed to $50 down and the outstanding amount changed $50 down. That's all we know about. We always know about the current state of our system. So state-based persistence basically forces us to work with a snapshot of current state. However, what we find often when we, for example, have an issue or we want to analyze behavior of our users, that we observe state changing, but we don't really know why the change transition happened. So things change, but why they change, we barely understand. So we can say, okay, we want to monitor changes of certain properties of state, and then we implement something like recording the reason for change on a specific field. In this case, for example, I enabled recording the status, sorry, the order status updates, and I want to understand why the status changes. So, for example, in this sequence of order processing, the order was pending, paid, shipped, canceled, returned, and so on, refunded, and then ordered again and paid and shipped. So there is a concept of time involved, and of course, looking at the timeline, at some point I enable the recording of history of status changed. So right in the middle, I say here, I enable the status recording. And then I get a history of changes. But what happened before, I don't really know. So, I mean, I only can record history of that particular field change at the moment I start recording this. So I don't have any previous history of that. I only have it from the moment I deployed a new version. And it only records changes on a particular field, and it increases the complexity of the system because basically I need to implement additional code to track changes of that particular field. And the more fields I need to track, the more complex the code becomes. So I can use audit log for that purpose, but it's very limited. I mean, first I need to implement it. I don't know what happened before I implemented it, and it only tracks certain things. So the problem there that in fact the changes of state, mutations of state are triggered by user behavior or rules in our domain, right? So in this particular case, I have an order and it changes status and it changed the amount that is paid and outstanding. And what actually happened is that we received the payment for that. So basically it represents an event. An event is a fact of life that happened, and we know that something happened and it has a name and it has some properties. So this is a piece of information that in state-based persistence usually get lost, right? So we can make state mutations explicit by using events. So events will allow us to capture the behavior. Why is it important? Is that, for example, if you look at this slide, it's the same as the one that I used to demonstrate the state mutations. So the total changed and the paid amount is the same, outstanding amount changed. So why all of a sudden the total amount and outstanding amount got decreased by $50? So we don't really know that. There could be two scenarios. For example, we applied a discount manually or automatically using discount code. So when we apply the discount, then the total and the outstanding amount change together. There was another possibility that, for example, the user has removed an item from an order, and the result of state change is the same. So basically, the order got $50 less in total and outstanding amount. But the behavior is very different. So if you want to know, for example, if your users are adding and removing items or applying discounts, these are two different use cases, and there could be pretty interesting analysis done for that particular behavior in order to execute something else on your e-commerce domain, for example, if this is the case. So you can engage in marketing, you can reach out to people if they want to buy this item still, if they removed it and stuff like that, which is completely inappropriate when they just applied a discount. So then I'd like to talk a little bit, so what can we do? I heard many words about event sourcing. People call it even the architecture. I use event sourcing architecture. I use event sourcing, what's it called? It's a pattern, of course, but something else. It's like, it gets a little bit too high of an abstraction for many people. But what I'd like to emphasize is basically a different way to persist state. It's not anything else. I mean, it's just a way to persist data. It's different, I know, but it's not. It's quite different, but essentially it's the same. It's just the persistence, right? So let's look how it actually works. So in state-oriented system, we execute commands in this fashion. So the user sends a command to the system to add order item. What we usually get in sort of, if you are you have reached the main model and you have applied DDD patterns, so you load the order state to know if you can actually execute this command, because you need to be sure that the command is legit. You call a method on your domain entity called add item, for example, and then you update the order state and it goes to the database. What I can tell you that using event sourcing doesn't change this picture a slightest bit. So you execute a single transaction, the result of executing a command, and that's how it is in state-driven systems and also in event source systems. It doesn't change at all. So if you look at details, of course, the details are different. So let's say this is our classically state-based implemented aggregate. So we have a method that's called, or let's call it entity. We have a method called add item, and it has the order item that we want to add. We check if we can add it. If not, we raise a domain exception. And if everything is fine, we just add it to collection of items. We change the total amount, and that's done. So basically, something outside of this method, something outside of the domain model is dealing with persistence. So it loads the entity from the database, and after execution, it persists the new state. So this is how it works in the in state-driven, state-oriented system. So when we execute a command, we have a command handler outside of our domain model, which loads the aggregate and passes the command to the domain model itself. And at the end, it mutates its state, right? So it executes a state mutation. So we probably have an application server or individual command handler that deals with persistence. So what does it do? The first line is it loads an entity from the store using the ID of an entity in the that comes in the command. It creates some, for example, it creates some value object. In this particular case, is order item. It then adds an item, calls the aggregate method or entity method, and then it persists to the store. So we say we have an abstraction or particular implementation, whatever it's called, entity store that needs to execute two methods. It needs to be able to load entity from the database and put it back. So again, this thing, this service in event source system wouldn't change at all. So I mean, yes, if we talk about repositories, for example, we have repositories, also queries and stuff like that, which I prefer not to do, and I want to apply CQRS. This is the general flow. So when an entity store has two methods, it loads something and it saves it back. It doesn't matter what type of persistence you use, the code doesn't change a slightest bit. So if we look at the concept of domain event, I believe that's very important to understand the pattern itself. So the domain event pattern is not related to event sourcing as such. And I think it's important to remember. Domain events can be used without using event sourcing. So for example, you can produce domain events and emit them in proc for other parts of your application running right now to consume and do something. It might break your transactions, but that's a different story. You can also emit domain events to the event bus and execute some asynchronous behavior. So there are a bunch of things you can do with domain events. So domain events are pretty useful on their own without event sourcing. I think event sourcing is just take it to the next level. So just want to cite Eric Evans in that regard. He says the domain event is a fully fledged part of the domain model. So it's a first-class citizen, and it's a representation of something that happened in the domain. And last time I talked to Eric, he said, and he added to this sentence is something that the domain expert cares about. So it's important to understand, because I've seen many implementation of event source system where people say this changed, that changed, and this changed, and basically it comes to what we call property sourcing, which I clearly do not advise to do. It's in my opinion, it's anti-pattern, because domain expert doesn't care about property being changed. It doesn't express any behavior in the system. What's important is that the domain event actually expresses behavior, and we in event source system we use that to capture the behavior, to persist it. It's pretty surprising for me that in DDD we talk so much about reached models and expressing behavior, but we've never been able to capture the behavior. We know how to execute it. We know how to express it in code, but we've never been able to capture and persist the behavior. And I think event sourcing is a very interesting part in that regard. It actually allows us to capture and persist the behavior and use it for many different purposes. So what is event sourcing in general, in very high level? So the same picture as before. So we have a command handler talk to the domain model. Just instead of loading the aggregate state, we load a bunch of events. We reconstruct the aggregate state from these events. And when the command is executed, we produce one or more events and persist them back to the database. So basically, we do not mutate anything. We just add new changes to the end of the log. So in some regard, it might sound very similar to how, for example, traditional databases take care of data consistency. So they have things like transaction logs or upstream, which basically allows them to reconstruct the state of the system based on the latest backup, for example, and applying transaction log at the end. However, transaction logs and upstreams are very technical. They do not capture any behavior. They just capture technical operations on a particular persistent pieces of persistence, like a table or a collection of documents. Unlike transaction logs, event streams actually have a business meaning, and that's important to understand. And if you build a system with property sourcing, so to say, it's very similar to transaction log. I would say just do transaction logs and don't care about event sourcing whatsoever. So how do we represent domain events in code. So we can write a simple record, immutable record, which has exactly the amount of data we need to convey as part of the transaction that has been executed. So we need to have an ID of our entity. We need to have something that represents some of the objects that we, like in this case, we added an item, so we can use another record or a typed record in this case, and then we have a new total of the order. If you see here in the share.order item, that's not a value objects. So we keep talking about separating concerns. So value objects is part of the business, and events only consists of primitive types or complex type that consists of primitive types, because the important part of the events in code is that it's going to be persisted, and it means that it needs to be serializable. Deserializable doesn't contain any rules, right? Rules might change, but history doesn't change. So you cannot apply rules back in time. You just want to keep it straight. So let's see how our entity changes when we deal with events. It's the same method called add item, and we pass the value object. In this case, it's the value object. And then we check again if we can do that, and then we calculate a new total. And basically, instead of just returning or adding, in the previous slide, if you don't remember, we were adding new item to the collection right away. But here we don't do that. What we actually do is we emit an event, or we apply an event that's called add that I showed in the previous slide, and we populate all these properties. And here I map value object to the primitive, to the shared complex object that is used across different events. So it's not the value object that I put there. And then I give it a new total. So what happens then? So how the collection, the state, so if I remember correctly, I can do it here like this. No, I don't even have a mouse. That's not good. What I want to say is that we do have piece of state inside our entity, which is the ID, of course, list of items, and the total. So how does the items collection gets mutated? Because we might need to execute another operation as part of the same transaction. Well, let's look at the base class first. So well, I should have actually added it, that it implements the base class or inherits from the base class, because otherwise, how would we know what apply method does? So if we think in very, very simplistic terms, so we have just a collection of changes inside that base class. And when we call a method called apply, we just put this event to the collection of changes. That's all we do. But again, it doesn't change this collection of items in this particular case, right? So it's kind of, and it doesn't change the total amount, right? So the new total is calculated and only put into the event, but it doesn't propagate to the entity state at all. So what do we need to do? This is the second version of the base class. So it has two methods. One is the method, the abstract method that needs to be implemented in every implementation of this base class, which is called when. And in when method, I actually do the state mutation. So what does apply do? It executes the state mutation in memory, so no persistence, and then adds change to the list, right? So let's see how it's done in the entity itself. So the code, the first piece of code is exactly the same. Again, I forgot to put the inheritance here, but you get the idea. And then I have this when method implemented. So here I look, okay, I got item added, and then I mutate the state. So why is it useful? Well, first of all, you can say, or I wrote it in my book. Basically, this pattern with domain events and when and apply methods can be used in state-based persistence, because what you get at the end of execution of the add item method is an entity having a new state, which you can persist to a document or relational database as you do before. You just added events to your workflow. For example, you can iterate through the list of changes at the end of your command execution flow and emit them to the bus. So again, no event sourcing whatsoever, but you introduced events. And these events are much better than, for example, trying to figure out from the so like constructing domain events outside of your entity in the command handler, saying, okay, I called the add item method on my entity. So now the command handler thinks, okay, I need to emit an event to the bus that's called item added to order. It's not exactly right, because then the part of the domain behavior is shifted to the command handler, which normally should have nothing to do with domain behavior. So domain events preferably are produced by the entity itself. And this pattern, like using apply and when, can be used without event sourcing, just to produce domain events for the outside world. And you know definitely that those events are correct, because those events are used inside your entity to mutate its state. So if you made a mistake there, you easily see that, right? So you cannot emit incorrect events. So let's move forward. So how do we persist those things? So basically, the DDD flavor, how I call it, event sourcing postulates that you need to have a place, a collection of events for each entity, and we call it an event stream. An event stream is identified by its identity, and this identity, or the event stream is identified by the name, and the name of the stream is usually constructed by the name of the entity and its ID. So by doing that, we can clearly identify this is the list of events belonging to my particular entity. So when you want to load entity from persistence, you just load a single stream. If you want to persist new changes, you don't mutate the state, of course, you just add new events at the end of the stream, and they're all ordered and it's all fine. So usually, the command execution triggers 0 events if it couldn't execute it or it has an importance check. So for example, something already has happened and the user by mistake sent the same command twice. Second scenario is that you produce 1 event, and another scenario you produce many events. As soon as all those events belong to the same stream, you usually are able to persist in one transaction. And that's what's most important in the command flow, that the command flow needs to be transactional. That's how you guarantee your aggregate boundaries. So you say aggregate boundaries, consistency boundaries. I want to be consistent. I need to execute all my things that triggers by one command as a single transaction. So in this case, you see that I have a stream name order 1 to 3, which is my order is the entity name, and 1 to 3 is the identity, and it has a bunch of events. So it first gets created, then I added 2 items, removed 1 item, and I finally paid the order. So you could imagine I don't have a code for the state-based persistence. You probably implemented this before. Just use object relation mapper, use document database, persist the state to the database, and you're done. So now here comes a bit of complexity. So everything that we touched before is kind of classic and with a little bit of tweaks introducing events to the domain model, but overall still not that complex. Here's a little bit of complexity. So again, I mentioned before that the entity store needs to have 2 methods, basically, load and save. So I switched them. So first, let's talk about save. How do we persist an entity to the using event sourcing? So let's say we have some sort of event database. So we can call it event store. So now I can say it because the product I helped to build called Event Store DB, An event store is a generic concept. It's basically a place that supports all these concerns that I explained about being able to read the whole stream and being able to write an event to a single stream. So save. So save, basically, first thing it does, it collects the changes. If there are no changes, it just does nothing because there is nothing to do. Then it creates, for example, then the database needs to have a certain type of events to save. They're more or less generic. They usually have some sort of payload and metadata associated with the event. So what we need to do, we need to serialize our event. Here the serialization comes. That's why we need to work with primitives. And then we just add this serialized event to the list. We need to give it a type because basically in event store, or event database is just a string that will help you to identify how you need to deserialize it back, which is not very much different from other databases where you need to know what you're loading and saving, in which table it goes, which collection, and so on. And then you need to find out which stream you want to persist it to, and then you just tell the database to append these events. So not fancy, pretty straightforward, a little bit more complex, if I could say it's compared with document databases, but much less complex if you think about relational databases. So imagine what you need to do to find out what has changed in the domain entity state when you deal with relational database. So you got a previous piece of state, you got a new piece of state. You need to look through all the properties using some wicked mechanisms and find out and construct SQL query that will be executed for that particular properties if you don't want to override the whole state. So people get tired of this and they use object relational mappers like Entity Framework, for example. Entity Framework has this nice feature of session and tracking changes in your objects. So you load the object, it creates a proxy for that object, and using a wicked proxy mechanism, it tracks all the calls to property setters to find out what you actually have changed in order to construct very specific SQL update or delete in that regard, or insert to support your update. I mean, yes, I know you don't see it, but I can tell you that the complexity is there and the complexity is tremendous. So when I recently, a couple of months ago, I tweeted like, yes, it looks simple, but Entity Framework has like 60 or how much? It's hundreds of thousands of lines of code, and all of that is needed in order to support the simplicity of the outside world API that figures out all these wicked things that you need to do in the relational database in order to persist the change. So, okay, I distracted a little bit. I just really get upset when people mention ORMs. So, okay, let's say load. So what load does do? The load again tries to figure out or figures out a stream name for this entity based on the entity type and ID. It reads all events from the stream. If there are no events, it just returns the default, the empty object. You can say, I don't want to return an empty object. I want to throw an exception. It's a choice. So, and then, or in this case, it just returns nothing. If it finds events, it constructs a new entity, and then it just calls this when method that we created before for each of those events. So if when methods are executed in sequence for all the events in the stream, at the end, you get the state, the current state of your entity. So if we compare this with traditional persistence, imagine that all the ORM code that you have is put in these methods. So I would guarantee you that the save and load methods dealing with relational databases would be thousands of lines of code. And still, all those thousands of lines of code that are hidden inside object relational mappers are trying to deal with things that we call impedance mismatch. So what does it mean? It's basically the mismatch between objects in an object-oriented world and tables and whatever foreign keys and stuff like that you have in a relational model. They might look similar, but they are quite different. So anyone who tried to persist an entity with value objects 3 years ago or 4 years ago in entity framework would know what I mean. It's really hard. And the entity framework team, I have to admit, they've done a great job to improve this, but we still have quite a lot of concerns and a lot of configuration to make it work. And I have this in the book, and I struggle with that quite a lot, just to figure out how it's done. In event source systems, this is all the code that you need. And this has zero impedance mismatch because you do not persist complex state. What you persist is small serializable objects, and how they're being applied to the state when you reconstruct the entity, it's up to you. It's just a bit of code. So without a reasonable doubt, we can talk about this during Q&A. The event sourcing eliminates impedance mismatch entirely. And that's another great benefit of this pattern. So I think we can just go through questions that we collected so far. And if we get enough time, we can talk about projections and reporting models and stuff like that. So I'll stop sharing for a sec. Let's go through questions. Do we want to have a dialogue, Pao, or?
I found your tweet about. Yeah, it was in May. You were pushing the ORMs and persisting domain object. And Jimmy was also trolling you with the outbox pattern as usual.
Yeah.
Yeah. Okay, yeah, we've got some questions. So there is a lot of people
From one
in
guy,
YouTube.
all of them, except
No,
for the
it's
last one.
it's David from that he's monitoring YouTube.
Okay, cool.
He's copying over from YouTube. Yeah.
So let's start from the top. All right. So yeah, that's a bit. Let's just see if I can answer something quickly, because the first question is pretty sort of, it's quite ubiquitous, so to say. So what happens when in your model there is a need to change the way you handle specific events? How can you ensure that aggregate reconstructs correctly? Well, you don't really handle events, so to say. Events are only used, it's like, let's say, let's get to the analogy of the transaction log. So what happened. So you recorded that something has happened and it has a name and it has certain properties. So how you apply this bit of information to your aggregate or entity, it's up to you. It rarely happens that you need to change the way how the event applies to the domain model or the object in the domain model. It only happens when you have a bug there. For example, you wanted to update a total, but you like accidentally multiply by 2. In this case, you really want to fix that in your code. Worst thing happens if you record those events or those actions or reactions, so to say, incorrectly. So then the major pain starts, I believe, when people make bugs in something that has been already recorded. Because event stores usually have no capacity to change events because they are immutable. That's the source of truth, and you don't want to manipulate the source of truth. So then you might need to execute some corrections. This is very similar to accounting systems. So for example, if I book a transaction for my company, I cannot delete it. When I first saw it, it was like a shock. How is it possible that I just enter some information and I couldn't delete it? It's just a bloody record in a database. Why couldn't I just erase it? That's not how the real world works. So for example, if you ever reply to all and regret it in 5 minutes or immediately, there is no way to return this email. Some mail systems are clever enough to hold it for a little bit and then you can revert it. But the damage might be already done. And sometimes you write something to people that you don't want to write and regret afterwards. But sorry, man or girl, you have done it, so deal with consequences. That's exactly how it is. So you can send a letter, you can submit a tax report or return with incorrect information, and what you need to do is submit it again as a correction. So that's very, very similar to how the real world works. So however, in majority of cases, you can catch the basic things if you just create a proper test suite and you know what needs to happen. So basically, you just compare the state you expect with the state you get, and that's how we deal with that. So how granular the events should be? Good question. I don't know. So the it depends. I can also provide a brilliant consulting answer. So let's say there are two kind of camps that continuously battle with each other. So one camp says the event must be thin, so they need to capture exactly the information needed that you want to convey and to mutate the state. However, another camp says, well, that's rubbish because you might have something on the outside that don't want to reach out to you again to ask additional information. So you just put it in the event because you already have it. And you don't use it to mutate the state, but you use it as an informational sort of information medium to the outside world. So as usual, the truth is somewhere in the middle. You might have domain events that are thin, and you might enrich them when you push them out to the world, because it's not exactly realistic that the domain events that you persist will be the events that are going out to other systems for integration, because we can discuss this. This is an interesting topic about using event sourcing for integration. And I would strongly not advise, I mean, you can postpone this moment when you start separating in domain events persisted in your store that belong to your bounded context and events that you publish to the outside world to consume. Because as soon as you, as long as you produce the same event to the outside world, you establish this as what we call published language, right? So everyone who is listening to you will understand your language, and they will write consumers that will consume those events and do execute behavior or create read models in there for their integration stuff. However, at the moment you want to introduce new event or you want to change the schema of the event, because it's all totally possible. You can just start producing new version of an event, keep the old one for historical purpose because you still need to read them from time to time. But then you break your published language. So then you start thinking, oh, Jesus Christ, I couple to the whole world now. So they all couple to me, to my domain model, to my bound context, to my language. I cannot evolve my domain model because I must produce what I have produced before. That's the moment where you start thinking, okay, I want to separate those events. So when you separate events, internal domain events and events that are going out, then you might find a need to enrich them, but you can enrich them at the edge. Another scenario that I have in my book is that suddenly I found out that events that I was producing were not enough. The information inside the event were not enough to create a read model. So, well, bummer. So I have a choice. First of all, I can start putting these additional properties to my new events. Keep the version the same. When you add properties, it doesn't matter because you don't use those properties to mutate the state. You just use them for read models. So you can start putting them in. And the read model, when they receive an older event without that information, they will reach out to you or to some other place to kind of enrich an event or basically get this missing information. In time, when you introduce new event with additional properties, they will just go on and you won't need this anymore. So this is the upcaster patterns. So you change event version and enrich it with information. You can also instruct the read model to put more or reach out somewhere else for the missing information. But usually, yeah, it's quite elaborate answer. You start with what you need. You never know what you would need, but you can always find a way to enrich later on. Because as soon as you keep all the information that you need to reconstruct the aggregate state, that's all information you need. Read models might need more, but they can find a way to find this missing bits of information. So sorry for a long one. Is it a good practice to have all entity logic and when methods inside a switch statement? Well, two bits. So first of all, there is no logic there. The when methods is very dumb. It's just taking the piece of state from the event and puts it in the piece of state in the entity itself. So there is no logic there at all. That's where the logic is still in the entity method itself. It's not in the when method. If we talk about the switch statement, no, it's just that I like pattern matching. And if you use F#, I would say that's probably a good idea. If you use C#, it's pretty verbose. Then you might want to split them. It's very easy to do, create a dictionary of kind of event type versus action or function, and then you execute it. It's pretty easy to do. There are a bunch of implementations like that. I think we use that more. I would say you can start with switch statement. It's just very obvious what happens. And then you find that it just grows too much, you just can consolidate it. You can also use a pattern that I sometimes use. Basically, the state it lives outside of the entity. So entity has just the logic. It's kind of, if we talk about functional programming, it's just a module. And the state is an immutable object. And then you can have another module that just have functions to apply events to the state and produce a new piece of state. Because like Greg said many times, it's just a left fold, right? So applying events in sequence, you produce a new piece of state every time. So it's a left fold of current state plus an event or collection of events. So I was waiting for records in C# to make it nicely done, but however, they ignore the reference types. So for example, if you have an array or collection of something, it won't be copied. So long live deep clone. We love it. We keep using it, so there is no way around it, even with the records. It's a bummer, but so yes, do whatever you want, whatever you find useful. So I think for functional languages, it's pretty obvious that you can very concisely describe this state transitions using the pattern matching, but for C#, you might choose something else. If you use another language, like in Go, there is no pattern matching, like we do. There are no switch expressions as well, so it looks nasty. So then you create a dictionary or hash map or something like that, a set of functions that create a new piece of state. So there is no practice around it, right?
It's like reduce for the front end as well, right? Reduce operation in In
Yes.
JavaScript, it's called reduce, right? Yeah.
Yes.
Yeah.
Yes.
This switch,
Let's not talk about Redux, right? So.
Yeah, but that
But in
switch,
fact,
it's.
if you use something like unidirectional flow in front-end applications with Redux, Mobex, or Vuex, or whatever else, basically all the actions. I don't have experience with React, but I write quite a lot of Vue. So you have actions in the store. These are commands. You have mutations. These are basically event handlers. And actions produce events, and they never do direct two-way binding like we used to have in Angular. They always go one way. It might sound annoying. Yeah, it might sound annoying, but actually it's a very good way to control things and then not allowing components to just mutate each other's state in random basis. So you have a way to control the flow. That's very nice. That's very similar. By the load and how many events can we handle without affecting the performance? It depends on what kind of persistence you use. If you use, for example, XML files, that probably would not be very fast, and one directory per entity. If you use event store DB, we usually say if you have less than 1,000, don't even think about it. It all depends on the law. It's interesting because we usually say that justification of CQRS that there is a read-write misbalance, right? So business systems are usually focused on reads. In ABAX, Pau knows this, we have a different kind of misbalance. We have much more writes than reads. And still CQRS applies because then event sourcing plays a very important role of allowing us to do aggregations, for example, upfront. So we do pre-calculated read models that aggregate some information that querying it would take a lot of time. But nevertheless, getting back to the question, yeah, less than 1,000, I would say that's fine. However, in my experience, business entities rarely reach that level of that number of events. So I keep talking to event store customers, a bunch of scenarios, what they have, and every time I hear that my aggregate has thousands of events, tens of thousands of events, I would say, get back to a whiteboard and see if your aggregate boundaries are correct, because you might need to have a smaller boundary. You might just create a too big boundary, and then you encapsulate too much or too little. So usually, like that order that I showed you, how many events it would have, maybe 20 max. So there are no such aggregates as, for example, we use this often as an example, like bank transfers, like deposits and withdrawals. I would guarantee you there is no such aggregate in real life. The transaction itself is an aggregate, but not the account. The account might be an aggregate, but it doesn't take care of withdrawals and deposits. It's something else. So you might reconsider. So locking race conditions. Well, yeah, that's actually pretty easy. It's the same pattern as you would do in relational databases or document databases. So document databases often use e tag. So when you load something, you get an e tag, and when you persist, you see if the e tag is the same, and if not, you throw the concurrency exception, optimistic concurrency exception. So you don't do locks. I never use ORMs these days, but before I was using Hibernate, and the optimistic concurrency with Hibernate was holding the version column in every table, or at least so to say aggregate root table. So what it will do, it will compare the version that is there, and if it doesn't match, it will throw the concurrency exception, optimistic concurrency exception. The same happens with events. So what happens is that every event in the stream has its version, its number. So it starts from 0 and goes on. And when you persist a new event, you give it an expected version. So it should be 5. And if someone managed to execute operation quicker and they get 6, or you already have 5, and then the expected version would be 6, you get optimistic concurrency exception. So this doesn't change. And how you deal with optimistic concurrency or in a command handler, it's up to you. It's exactly the same as in state-based persistence. There is nothing different. So it's basically versioning of the aggregate state. Yes, isn't there a price to pay where your entity stream has many events that be applied to a lot of the object? So I think I answered that already. So if you really have thousands or millions of events in a single stream that represents the business entity, I would urge you to reconsider your boundaries. It's rarely happens. So I've seen it before in practice, and always we found out that our boundaries were incorrect. So we just didn't think that much. So we went to the drawing board and we put new boundaries in place and found out that how we can split aggregate. Oh, Kafka. I love this. So if we have no access to event store, I guess event store DB in this case, we change the name, but we keep using it interchangeably. What do you think about Kafka Kinesis as an event store? Okay, Kafka has one big flaw. Yes. So not flood. So the flaw is that Kafka is basically a message broker. It's a persistent message broker with possibility to replay and a retention period. They introduced immediate infinite retention recently, but still. So what does it mean? Basically, you have a topic, right? And a topic is, I could imagine that could be your aggregate type, for example. Let's say order. And then you shovel all the events in there. But then you can't reconstruct your aggregate. You have no way to read a single stream. There is no such concept of an entity stream in Kafka. There is no way you can do that. So Kinesis is the same. It's basically producing. It's great for event-driven systems, and I have to say in ABAX we use Kafka for different purposes, basically to store events. But it has nothing to do with business and domain-driven design and event sourcing as such. So it's the broker, and we use it as a broker, and the log, and we use it as a log. But I don't even I can't imagine how it can be used for event sourcing. So there is no such thing. You can't have partition per aggregate. It's impossible, right? So it's like how consumers group work and stuff like that. It's just no way you can do it. I know that people use event sourcing with Kafka. They call it event sourcing. The problem there that they cannot use stream of events as a source of truth. And in my view, it's a big problem because then you need to keep something on the side, basically a projection read model that would serve you as a state of an entity that you use as a source of truth. But there is always a gap between you applying an event to the topic and then this state's getting updated. So you might execute your decisions based on this tail information, which is not good at all. So, and I don't know why I don't have access to Event Store, to be honest. I mean, it's much easier to deal with Confluent Cloud and stuff like that. So, yeah.
Yeah, that's to follow up the question, what options do we have for persistence, right? Because
Yeah, I would say that, yeah, Event Store DB is built for that particular purpose. So the reason for it to exist, it was actually dogfooding on like Greg looked around with a couple of friends and say, Jesus Christ, there's nothing. So let's build something. But there are options. So for example, there is a library called Martin, and since we are on .NET Meetup, I think everyone can just look around and see, find something. So Martin uses Postgres as a persistence for event sourcing, and Oscar, one of the, it's created by Jeremy Miller, and one of the maintainers is Oscar. So he is doing some talks and meetups. Most of them are in Polish, unfortunately. So I don't know if you can find something from that field. But as far as I remember, he's joining Event Store as a developer advocate, so he might change his focus. But he said he wants to keep maintaining Martin. We have no problem with that. So another option could be like SQL Stream Store created by Damien Hickey. Also, kind of the source or the reason for them was exactly that. They couldn't get Event Store DB into their tool stack, and they decide, okay, we have SQL Server, so what can we do? And some of the people that created SQL Stream Store are working for Event Store now. But that is an option, and it has very similar API for the client. I know that some people use Cosmos DB. Cosmos DB has a bit of a problem with costs, but if cost doesn't matter for you and you are fully in Azure, that might be an option. Cosmos supports Mongo API, but the big difference and big advantage of Cosmos DB that our change log as such is unlimited. So that's pretty interesting because you can basically have some sort of event source system with that. So I wouldn't recommend using MongoDB with OpsStream because OpsStream is effectively the ops stream operation stream, and it has limitation in size and time, and it just doesn't give it a source of truth whatsoever. It will be purged. So that's the important thing to remember. So there are a few options. Is that you would need to build something, or you can use library and try it out. So what happens when you have bug and you publish an event that just shouldn't have been published? Okay, I gave an example with reply to all or writing a nasty email that you want to return, but you can't because it's gone. So that's exactly the same. You deal with consequences. Usually the consequence is that you need to have some sort of compensating action. So this is where complexity might hit you. But again, it has its benefits because you would be able to see compensating actions. Unlike in state-based systems, I've seen many scenarios where people fixing consequences by executing some queries in production, and then because it happens usually in the rush, under stress, it might not end up really well because you might execute things that you weren't supposed to execute, and you end up in even the worst state you compared with what you started, and there is no way back. And then after 4 hours or 16 hours in that regard of mocking around with all these updates, you just say, fuck it, I go back and restore from backup and call it a day, and the data is lost. This never happens in event source systems. Yes, you have to emit compensating action, but then at least you have it explicitly done, and you can track, like, aha, I fixed that by this event. So is it good or bad? I couldn't tell you. In my view, it's actually good because I've seen too many problems coming out of people trying to fix state of the system live in production by hand. So it's just that's my opinion. So GDPR is, we actually have, okay, I have 2 questions about GDPR. So let's combine them. So Andre and Stefan asking about this. GDPR, I think most of the people know. For those who don't know, it's basically not a new issue. It's the issue of PI, personal information stored somewhere in the system and needs to be protected, or GDPR just introduces a new requirement that you have a right to be deleted or request a removal of your personal information from the system. So Stefan says, is event sourcing in GDPR contradictory? Well, no, I don't think so. So how, again, it's just a way to persist data, right? So you have, let's say you deal with persistence-based system, or like state-based persistence, sorry, state-based persistence. So you have PI stored somewhere. So what do? You delete this PI. The difference is that you cannot delete individual events from the stream that contains the PI, but you can delete the whole stream. So you need to design your system, and that actually applies to state-based systems as well. So you can, of course, anonymize things in the persistence or in state-based database. However, if you read the document carefully, there are a bunch of restrictions that apply to, or they clearly distinguish anonymization with pseudo-anonymization. So they say pseudo-anonymization is trying to anonymize data you have and keep the data. The best way to anonymize is to remove the binding or the link between the actual person and everything else that you want to keep after the person requests to delete their information in the system. So GDPR clearly doesn't allow pseudo-anonymization. It's not going to fly. If you do that, you're probably in GDPR violation. So what they really require, that there is no way in your system, like they formulate very interestingly, they say using current and reasonably kind of guessed future technologies to guess who that was. So this definition is very broad and very kind of not precise. So what kind of technology, future quantum computing, could you say that I encrypt the private information and throw out the key? Would the quantum computing allow me to deconstruct it back when it, can we say it's reasonably recent future technology? I don't know. This, I have no answer for that. It's typical law when you need a lawyer to actually transcribe it for you. So the recipe is quite simple. So I prefer a simple method. Keep the PI in a separate stream. Delete the stream when you're done, and use the ID. So every time I see things like person name and stuff like that flying around in events that only feed read models, I say, what are you doing? So that's bad practice overall in general. So another option, if you can't avoid having this information in events that kind of cannot be separated into individual streams, you can apply what people call crypto shredding. So basically encrypting PI with a key, getting rid of the key when you need to delete. And I've done it before. Interesting enough, it was all everywhere. So it was in the events, it was in Mongo in the projection and the read model, and in Elasticsearch in the read model, and it all worked. So that's a very safe way to do that, because it's just basically converting something readable to something completely unreadable. If you don't have a key, there is no way to find it or deconstruct it back. And I don't think you can even make it this way that every time you put a name, you put it twice, it looks different, because proper encryption algorithms produce different results depending on time of the execution and stuff like that. So it's much better way, and it can be applied to any system, not only event source system. So I think we have an article about GDPR either published or soon to be published in Event Store blog. So just watch the space. I don't remember. I think it was published. So When one or more attribute is updated in UI, how to apply these changes to our model and the UI user updates first name, last name, and email should we submit change. So, well, I would say I'm a big fan of task-based UI. Some would say that it's actually the event sourcing that triggers me to change how the UI works, but I believe that's a good thing to do overall. I hate forms with 25 fields that and one save button and then go figure what just happened. It hurts any system. You actually lose control on what's going on. You don't know what your users are doing. So and it's usually very bad because it just doesn't create comfort for users when they see things like I can change my name, I can change my address, and I can, by the way, change my password. They get confused, like if I press enter now, I save it, would it reset my password? Would it empty it or something like that? Or the worst case, you have the validation there, you need to put your password and stuff like that. So it's like if I want to change my first name because I made a typo, that doesn't trigger any business behavior usually. It's just sort of metadata about myself as a person. So it has no effect on the system behavior. What about the email? I don't know. If the email is your logging, many systems don't even allow to change it. So you need to go through the special procedure of confirming your email and stuff like that. If you have this kind of behavior, so names are fine, just change it. But if you're in a bank, you can't change your name because they need to verify your identity again. If you change your email that you use to log in or for any other decent purpose, then you often need to verify. So there is behavior executed by certain things being updated. And I would really not like to combine those things together. So if it's just a bunch of metadata that has no meaning and doesn't trigger the behavior, just combine it to one command, combine it to one event, user data changed, whatever. But it's not often to be seen in business systems. So as soon as some actions trigger behavior, I would like them to be separate. There are legacy UIs that you say, I can't change the UI that easily to task-based because basically it's just too convoluted. Then you need to figure out this yourself. We've done it before. So the UI might say, okay, if something hasn't changed, I send you a null or undefined, not an empty string, but really null. And then you just don't change it. You just figure out yourself on the back end what you need to do. As I said, the command execution can produce one or more, or zero or more events. It could be one, it could be five. As soon as they go in a single transaction, you're good. But really, I think the good UX is based on task-based UI. I strongly believe in that. Okay, so do you have suggestions? I used to stream on the main events and other integration events, because otherwise we propagate integration events just to the bus and not, yes, then we lose the order. Well, you don't need to propagate it to the bus. You can propagate it in Kafka, right? And then you get everything in order. It depends on your infrastructure concerns. So if you want to keep integration events, you might consider storing them. The need for storing integration events might be useful because then you have the ability to connect new systems and they will recover your kind of their own representation of state based on the stream that you give them. But there, they don't need things like aggregate streams and stuff like that. They just need ordered, if you need ordered, of course. So I would say that a lot of scenarios are covered by just publishing them to the bus. They transient, they just disappear, and then when you need to execute, start up a new system that want to integrate with you, they need to migrate something. If you want to keep them and give them the ability to reconstruct, you can use other persistent methods. You can use the same event store. Again, you don't need to have, like, I have my bounded context that consists of 20,000, 100,000 aggregates and there's 100,000 streams, it doesn't mean that I have to have 100,000 integration streams. I can have a single one, just shovel it there, and maybe even set a retention period of 14 days or 30 days or 90 days, whatever you want, just get rid of them afterwards. So these events, it depends on the scenario, important or not. You can use a different piece of structure. Like I said, there you can use Kafka. You can use Kafka compacted topics. Off you go. So just have a single one always at the end to represent, like compacted topics. If you don't know, it's basically a bunch of events that represent the current latest state of a certain entity. So then you just convert your business events to this piece of state. It's kind of read model, just represented as a topic. When you read the whole topic, you get a copy of the system, of the current snapshot of the system. Just listen to that again, you get new state all the time back. But it has nothing to do with event sourcing as such. It's basically, it's very good for integration though. So, are there any advice using event sourcing with necessity changing the past? Well, that's interesting because a few months ago, I had a talk on DDD Norway meetup, which is recorded. It was already during the pandemic, so it was no real session. It was a virtual session like we have now. Thomas Pierrat, he was talking about these things. So event source system that deal with the past. So basically writing events that represent something that happened back in time. The talk is mind-blowing, very interesting. And they had a concept which actually can only be done with event sourcing, surprisingly, where they were recording events with applicable date. So you record an event now, but it applies back in time. When you replay those events, you order them by that date. So you can have the possibility to reconstruct the state like it should have been. Although at that particular moment back in time, you didn't even know about certain thing that happened. So this is a very interesting pattern. I never used it myself, but if you're interested, there is a talk on YouTube about how this can be done. So I would say it might be very, very interesting to actually have event source system that deal with the past. But it depends on what you actually want. If you just want to change the state based on something happened in the past and you ignore the consequences, that's one thing. But if you really want to see how it evolved and what you knew, what you didn't know, and how would it have been and how it was, for example, if you, let's say you have a stream, right? And at the end of the stream, you add event that should have been applied in the past. You just say applied date, like 1 year from now, back in time. What you can do, you can reconstruct the state 1 year or 9 months back in time, like it actually happened, based on what you knew, and execute what's say the pattern that's called what if. So you can reconstruct the state based on the applied date, knowing what you know now, and compare this and decide. So it's very useful for predictions and analysis of missing information and stuff like that. So again, if you're interested, you can watch the talk. Right. So what do you think exposing events from the store directly, for example, publishing all events to RabbitMQ instead of using integration events? As I said, it's perfectly fine when you start. The problem with that is that there is a good practice, like you building a microservice or abandoned context service that talks to the outside world in a pub/sub fashion. So you just say, okay, this has happened in my domain, go figure. That I am telling you what happened using my domain events. It comes to the API design and contracts, right? So when you do that, you basically expose an API in form of events. It's not different from anything else. It's not really related to event sourcing as such. So you produce events to the outside world that tell others what happened in your bound context. So this is your API. APIs must be stable. You don't know who consume your events. So let's say you want to elaborate in your domain. You change your boundaries. You change aggregates, you split in two, you merge them, and stuff like that. You create new events. So how do you convey all this information to the outside world? It's really hard, especially if if you have a company of 5 people, probably you don't need stuff like that. You don't really care. You can have a monolithic system. But if it's a really kind of many teams involved and stuff like that, then we get really pissed if you start changing stuff. You basically start changing your API. So imagine that someone tells you today, GitHub says, okay, I changed our APIs and all the APIs are not supported. There will be thousands or millions of applications that actually stop working immediately. So I'd say to keep control or to keep your freedom to iterate in your domain model, to evolve it, because domain models, again, they represent your current understanding of reality and domain, and they evolve. You couldn't avoid this. You always evolve your domain model. To keep this freedom, at some point in an application lifecycle, you want to start separating them to keep the contract more stable, but keep your domain free for changes and sort of don't get this burden of saying I need to keep this domain event just for the sake of integration. But nice thing is that it can happen at some point in time, later in time. So you start today, and maybe it will happen in 1 year when you start iterating your domain model, introducing breaking changes in events. Then you say, okay, I will support all the events, all the contracts, and I will introduce new API for the future. I will support both APIs because you say I can upcast them or downcast them to the old API, and I will produce new events as part of my new API. But that's the moment where you start separating them. So it's basically to isolate you. So we have a very complex question, which I need more information. So probably we need to have a dialogue, but unfortunately the question comes from YouTube. The question is, any novice programmer on these technologies? Well, DDD is not a technology, it's a state of mind, basically. And CQRS is the pattern to separate reads from writes. Event sourcing is persistent mechanism. So it's a bit mixed. Okay, would like to do a new project in this technology. The result is fatal. That is what confuses me. What does it mean, result is fatal? I need some help there.
Yeah, I can play the role. I don't know. Yeah, but yeah, I had that in a lot of projects. So because I've applied event sourcing in some projects, but every time that someone took my project, right, because I'm moving, was rewritten completely because it was too complex. You cannot do updates right on the data once it's so you have support, and support usually learns SQL, right? Because then they can fix data easily. So that's a quite common pattern, and then you get stuck with events. Yeah, I would say it's that the relational database. It's easier, right, for most of the people. So for juniors or for people that are starting, right? So.
I mean, that's quite different from this question. So the question is like, I started or someone started to apply this patterns and they get a complete disaster. Like just doesn't work. I couldn't ever. I mean, I failed many times, but my failures were like people complain, right? So it's like they want to change something, and every time we look at the source of the issue, it's like not understanding the domain, not understanding, not being able to build the correct boundaries, not knowing the basics like slow moving data, fast moving data, finding out the aggregate boundaries, finding out where the consistency is. I'd say if you can produce a decent domain model and use a state-based persistence for you, there are very little barriers and very little chance of failure if you switch to event sourcing. So there are much more benefits. But if you can't produce a decent domain model, I'd say that probably, yes, you are up to failure Because if you try to build event source system using property sourcing, I mean, that's just useless because nobody sees the value, and I barely see any value in that. Some things cannot be implemented. Like, remember our current case with trips? We just struggle so much with the state-based persistence in a table that gets 1 million records per day, and a bunch of queries that go in that table and query things like crazy with inner outer joins on 25 different tables. Now we can clearly see that with event sourcing, we can produce a variety of very optimized read models that would solve most of the performance issues, if not all of them.
So maybe the question is if we should start with that, right?
I would say,
this...
remember that I showed you the code that was the entity code that was producing events and applying it straight away and mutating the state. I would say that if you take this as a basis, keep persisting to the database like the MongoDB or SQL Server, it still works, and you will get much better domain events that you want to publish to the outside world, one way or another. So that may be a good start. If you know that your domain model is right, and if you get proficient in modeling and you actually figuring out how to build proper aggregate boundaries, then it's much safer ground for you to start implementing event sourcing. If you have no knowledge of DDD, no knowledge of CQRS, no knowledge of event sourcing, probably starting with event sourcing is not the right thing to do unless this is what is required by the business, because there might be things like now we got this requirement of logging the changes. I mean, logging changes on the side based on database changes is a freaking hard job. There is pattern how to integrate with the legacy system using event sourcing by putting a trigger in that every table in the database, listening to changes, figure out what actually changed, and try to produce something meaningful. That's bloody hard. I've done it so many times, and actually it hurts. It hurts really because someone goes to do a massive update, and what first thing they do, they disable your trigger.
Yeah, it's
And
killing
they
the
enable it afterwards and say everything is okay, and then you lost a bunch of changes. So I mean, I remember the talk of Udi Dahan on the DDD Europe event sourcing events that I curated. He did a keynote. He said 90% of cases, or 98% of cases that people advocating event sourcing kind of present as a valid use case, they can be solved by change logs or just logs and stuff like that. I don't agree, because I deal with change logs too many times in my life, and I would say it's just pain in the ass to do. It's not easy. I mean, if your building software doesn't have any behavior, there's no need for event sourcing, right? If you build a bunch of forms to manipulate static data that has no behavior whatsoever, why do you need event sourcing? You don't even need domain model. You can just write straight to the database. But when you see software that writes to the database, and then there is a bunch of things happening in store procedures, checking conditions and validating this and executing a different kind of behavior. And our brilliant case is like store procedure. On the outside, it looks like a call store procedure to persist a state, and then store procedure puts something in RabbitMQ using CLR, which you cannot migrate to the cloud because CLR store procedures are forbidden in the cloud. And then what do? And then there is a bunch of asynchronous behavior executed outside. It's like, yeah, okay, where is the simplicity? It's not simple. It's insanely complex. It's just that you shift it to somewhere else.
Yeah, the
The easiest,
ORM. Yeah.
in ORM, for example, you shifted
Yeah.
your responsibility of figuring out how your domain objects need to be persisted, and you ignore the impedance mismatch up to the point when it actually hurts you really hard. So when you couldn't find a way to persist it anymore, and you start to manipulate your domain model structures and behaviors to embrace the database. That's probably the last thing you really want to do, to design your domain model based on the constraints of your database. So I'd say everything has trade-offs. I agree. So the basic event sourcing is easy. When you start dealing with compensation, event versioning, migration, stuff like that, it can become hard. State-based persistence has many, many flaws. We just know how to deal with them, but it doesn't eliminate this complexity. It just says, well, we know it's always seemed to be less complex, because what does it take to execute 25 SQL queries, collect all the necessary information to correct the state, and then you execute an update? But someone spent a year to figure out what you need to do. I worked in one company, product company actually, and there was a mismatch in warehouse stock and the visible stock somewhere else. I worked there for 3 years, and there was a bug. We never were able to figure out what happened, why and where in the system the data got in invalid state. And what we deal with is always in a state-based persistent system, we deal with current state, which is incorrect. It's not eventually because it's not stale, it's just wrong. And what we can do is to execute an update and fix it. So what we had is a runbook. We executed a few statements to figure out where data got mismatched, to figure out the correct values, and execute update in database to fix the state. 3 years time, I worked there for 3 years. We never been able to find this bug. I bet you money we could have been able to find this bug in no time, in like a couple of days, if we would record the behavior of the system using event sourcing or any other way, but not the logs, because in logs you can't find anything anyway. So
yeah, I think coming back to the question, there is a halfway. You don't have to go full event sourcing, right? And it's what you explain in your
absolutely.
book. So yeah, for the guy asking, I think, okay, I have the question in YouTube here, but anyway, I will recommend your book, basically.
Yeah.
So yeah, here you have, and here you have actually in the first that book, it's like a workshop, and you can see how you can go for the application layer. You can build it, and you don't have to go full event sourcing. So you can use a normal database. So and then you can switch, but you can work with events, and this is the most important part. So I will say the DDD, the events that people take care. So that's the thing, right? So not
Yeah.
event sourcing. It's actually just how you persist, right? So
Yeah. I
but
think that's
people,
important
yeah,
misconception, that is kind of architecture or whatever else.
yeah,
So
exactly.
it reminded me of I have I bought it many years ago, the online class of Greg Young. It doesn't cost much. I think it's like $200 or something.
I have it. Yeah, I have it. I bought it.
So there is one piece of it that's called the failed event source system, where Greg actually explains what happened when you deal with state-based persistence. You want to publish events, and then you deal with two-phase commits because they don't execute in a single transaction. People say, that's why probably Udi advertised it. He said, but you can use in Service Bus to publish events to the outside world so they can integrate, and you can keep it in the audit log. For example, for MassTransit, I built audit log because it wasn't there, and you can persist commands and you persist events, all messages in some sort of database to look at them later. This is just a log, right? This actually has its value. It's not what Jamie complains many times is that people advocating event source and saying you have full audit log. And I agree with him that's not exactly true, because you capture the state transitions, but you're not always able to capture the intent, because let's say the command hasn't been executed. The command came to us, but we said no. We have a choice, of course. We can produce the failure events and persist them to the failure stream or the same stream, just for the sake of having the history of things. But it might be idempotency issues. Like we said, there is nothing to do. We already executed it. But you want to keep the log of commands. So Brighter, for example, by Ian Cooper, is a command sourcing
Yeah,
library. So they persist all the commands. So then I can change the command execution logic, and basically you end up in a different state. Well, arguably better or whatever, depending on your scenario. Some people prefer that. So to have full audit log, you probably need to keep commands. So in that part of the class, Greg says that, okay, let's fix it. So let's store event in the table together with the state update in a single transaction, because we keep it in the same database. And they say, oh, DBAs love it, because then you have a source of truth, which is basically the event log that you can reconstruct any state using those events. And there's just one step towards event sourcing.
yeah, you are almost
You just drop the state and say that's my
yeah.
read model, right?
Yeah.
You can keep it fully consistent, by the way. People say read models are always eventually consistent or casual consistent or whatever, stale, right? You don't have to do it. You can do it right away in the same transaction and keep it in the same store, if you will. You just can't use event store, for example, for that, because then you can. No, you can't, because there will be different stream. So you will need to persist it to a different stream. There is two-phase commit. So potentially you can use something like SQL Stream Store and persist the state at the same time, or using ORM in the same transaction. You can just keep your events as a log on the side, and then eventually you find that why the hell I keep the state, because I can rebuild it all the time at any moment. So I will just keep it and treat it as a read model. So it's always a choice. But getting back to the original question, I don't see inevitable failure, so to say. I experience sometimes the opposite, like recently our colleagues came to me and said, look, there is part of the system that is event sourced and part of the system that's for simplicity is persisted to a document. And we have troubles to actually create a proper read model for our UI. We need to reach out to the read model that's built from event, and we need to enrich it, calling the API of that other system. And we want to event source that system too. So that's the other way around. So people don't want to switch the event source system to the state-based because they see the value in that. They instead want to switch the state-based system to event sourcing, although some of the team members were behind the decision not to event source in the first place. So they just reconsider and they say, okay, let's just do it, and then we're good. So
It's
again, I don't.
all these ideas are connected, because if you want to do task based, you cannot do it without proper backend. So it's like all it's connected, and publishing integrated events outside, it's also connected how you persist and in the database. So I would say, if you want to build from the front end to the database something that it's task-based, reactive, in a functional way, using functional programming, because functional programming, I think, it's key as well in that architecture.
Yeah.
So you need to go in that direction. If some of the piece, if one of the pieces it's not built in that way, you will have problems.
I can give you an example. Years ago, I was doing a pet project for, like, I have a holiday property in the mountains, and I want to automate this because I got tired of supporting it. So I figure out that. So that's let's say it's very similar to Booking.com or Airbnb in that regard, but just for single property. So what I've done is that I thought that it's a booking, right? So you place a booking, I confirm the booking, so it's free at that time, and then everything is around the booking. You pay it, and then you check in, you check out, and that's it. So after a bit of time, basically after running it, it actually went live production. So I had a tablet on the wall. You can type your booking number, check in, and do the payment and stuff like that. I was struggling to find free spots in the calendar. Like, how do you intersect all the bookings in the past, in the future, or current in the future to find if the property is free on that particular day? It turned out to be a very hard problem. And what I learned later when talking to Iran, Hout and others that were building scheduling system for medical purposes for healthcare institutions, they came to the concept of a day. And that's exactly the concept I came up with when I was reiterating on my domain model. So I'd say if I have every single day, 1 year upfront, as long as I allow bookings to take place, then I would say everything that happens during the day for that particular property or for collection of properties in that regard would be recorded in that day. And then I would say, on that date, property is busy, right? And at that date, there is one check-in, two checkouts, and I need to order some service to clean up the apartment, stuff like that. which is pretty useful. So in order to find out what needs to be done that particular date, you just look at a day and you see everything. So there is someone checking out, someone checking in, there is a gap between, and during that time, they need to clean the apartment. So guess what? I have a bunch of bookings and I need to convert it to days. It turned out to be like gigantic amount of work to figure it out. And I would say if I just event sourced it from the start, using my old domain model with bookings, I would be able to convert it to days in no time because there is a booking, it has a start date and end date, it's paid, so I can just propagate to the date. I do the migration. I will have a day as a read model in that regard.
Mm-hmm.
I would migrate my domain model to embrace the concept of the day later. It was all possible in my mind, but looking back in time, I already had a system that works that I just couldn't cope with. And I needed to do a lot of work to figure out how to convert this model to a new, with a new insight that I gained, having this system in production. It was really hard because I don't have any bloody history. I just have something that is right now visible to me.
Yeah.
So another case that I have, like I want to do our time tracking thing with Jira and GitLab stuff, right? So where do I start? I think I want to write the simple domain model that would just receive calls from one system when someone books time on that issue. So what do I need to do? I don't know how the model look like, but I know that something happens. So someone booked time on the issue in Jira and I wanted to propagate it to GitLab or other way around. So how I do that, I don't yet know, but I already know what happens in real world. So what I could start with, I would record this as events and figure out what to do when I have a lot of enough information to actually elaborate and reason about the model and actually come up with something. But facts are facts. They are not changeable. I know that someone booked time on the issue. There is nothing else, right? Someone put a comment on the issue. Someone created an issue and closed it. It doesn't change because that is what happens in real world. It's just start recording them. I can figure out the domain model later. Surprisingly enough, I find it very useful and much easier to implement than start to have a design rounds for weeks and figuring out how to build my domain model without having any data and not even seeing the pattern of how things happen. So I started recording in advance and in time it's like, okay, that makes sense. Okay, then I can do this. And I can do that. And then my model doesn't fit. But the collection of events that I have, they don't change. They are the same. I can produce different read models. I can produce different reactions on them. I can replay them back and forth and stuff like that. But they just stay there, right? So that's I also find very useful. Sometimes you just want to record things just for the sake of it and look at them later on, sleep on it, and then decide how your domain model will look like.
Yeah, it's better to have the facts than just the last snapshot. So
Yeah.
that's much better. You can. Yeah.
Yeah, because if
Yeah.
I would just record this state changes, these facts in the state, I would hardly figure out the behavioral pattern of people that are doing these things, and I would not being able to execute an analysis on that, and I would miss the opportunity to build certain interesting read models. So yeah, integration events. Should we store integration events? As I mentioned, you can. Again, it's up to you. You can store them with a retention period. You can store them unlimitedly. The risk of storing them unlimitedly that people that will read them will need to support all the public contracts that you used to have back in time. So one of our colleagues, for example, suggests to use Kafka compacted topics because that represents the state. So that's useful because you basically don't need to know what happened like in the past. If you are on the outside of your domain model, why the hell you care? You need to know the current state. That's very similar to the migration from state-based system to another state-based system. So if you really have an external system that's interested in what happened in the past, you might persist them unlimitedly. It's up to you. It's depending on the business case. I couldn't give a generic advice. So I know that in many cases, just publishing events to the bus solves a lot of integration problems. It's much better than nothing, so to say. But you can keep them. You can keep them as a snapshot. There are many patterns that you can apply by dealing with integration events.
Yeah, I
So,
guess you will like that one. Yeah.
okay, what's the difference between time series database and event store? Okay, I deal with time series databases recently, just a few weeks ago, in particular InfluxDB. So, time series database are they target a very specific need. Basically, they record measurements, and I got burned by that. So I wanted to store events. They're not designed to store events. Time series databases, basically, what they can do for you, you create a bucket or whatever else, and you start storing things, measurements with certain tags and the value. So there is always one single value and a bunch of tags. All the tags are indexed and the value stays. So value cannot be queried. You can put some baggage items on that also cannot be queried, but they're just ignored in terms of just persistent. You can't query them. You will get them back when you query by tags. So first of all, you start thinking about cardinality. I mean, time scale is, for example, handles high cardinality better than influx. Influx sucks with high level of cardinality. What they told us, you couldn't store events per device because that's just high level of cardinality because you have 250,000 devices. We say, oh, okay. GUID is not a good tag because it's just purely random and upper bound. It's not upper bound and it's like, it sucks. So, okay. Time series databases are very good at compressing data because what they do, if they receive the same sensor value over several measurements, they only store the timestamp. You have nothing like that in events. So, I mean, it's just completely different story. So they they target, like, you store sensor data with tags over the period of time, and there is an ID which is determines your cardinality, or not the ID, all the tags that you put, which you want to index, form form a cardinality level. So you have 3 tags, and each of the tags has 10 values. You get 10 multiplied by 10 multiplied by 10 cardinality level. So it's not designed for that. And they're aiming for efficiency by querying between 2 timestamps, which you never do in event source systems. You don't care about timestamps. You basically read them all, right? So I'd say it's a different story. And what we tried to do, we were trying to store position data. Like, it's not event sourcing at all. It's just a log of positions from hundreds of thousands of devices in time series database, which seemed to be a perfect match. And even that didn't work. So we had to go with different type of persistence. Then we come to something like BigQuery in Google or Athena in AWS and stuff like that, which is designed for this kind of stuff. And in order to query BigQuery, for example, it usually it just takes 30 seconds to query. Terabytes of data. Okay, 30 seconds in the UI. Okay, deal with that. I don't want to be that user. So that's event store. The proper event store has very simple characteristics. So you can put events in the stream. The stream is a virtual construct. So event store doesn't have a concept of streams going to different files. It's just a chunk, a file on disk, linear, append only. But there is an index on top of that. An index allows you to actually find all those events in all these gigantic files that belong to a single stream. But you need to have a single ordered stream of events in order to construct read models for your bounded context, or maybe even put it across bounded context and compose read models for reporting. So none of these characteristics actually apply to time series databases. Fortunately, unfortunately, fortunately, because then we will be out of the business. unfortunately, because there are interesting products, but they have very specific needs. So I wouldn't mess up with them. So what do you think about using big frameworks like Axon? That yeah, right. I would be, I would try to kind of reserve myself from saying anything about Axon. I think they do have event store, by the way, if we want to test performance-wise and stuff like that. I think Axon delivers very good developer experience, but again, Axon, in my opinion, is very opinionated. For example, they have aggregates that are command handlers, in fact. So message handler aggregates, there was a bunch of discussions like, should you do that or not? I was a big fan of that before, and I decided that it's not for me now, because basically I want to keep my domain model pure. So again, there are discussions like, should you keep your domain model pure or should you keep it complete? I'd say that I lean toward completeness of domain model, but again, it doesn't have it. I would not have any kind of dependence on infrastructure, commands, and stuff like that. So I like value objects. They need to be constructed from commands. Someone needs to take responsibility outside of my domain model to give me the information I need to execute certain action. So the risk of big frameworks that are imposed by someone else is basically you need to comply to them. You like it or not. So they might also impose some limitations what kind of infrastructure you can use. So it might bring you a short-term benefit in terms of you can start really fast, but then you live with it forever. I know that some colleagues from a neighbor town built a big framework. I wouldn't call a name. And they were advocating it, and they went to conference, and the big company in Norway came to them and said, okay, want to use, it looks awesome. They were going from the UI down to the database and supporting tens of different structure types for persistence and a lot of stuff. And afterwards, in a year time or few years back, we got a guy who worked in that company using that framework, and he said, we couldn't see anything running in production for months because some people, there was a team, basically, they dropped support in the framework. The team in that company supported framework and kind of bended it to their needs. And another team was producing a bunch of code that's supposed to work without being able to even execute it because there are so many things you need to do in order to actually make the whole system running. So in my opinion, that we do have in ABAX and the companies I worked before, we used to have our own home-baked things. So I think it makes sense to get an example. We were discussing it in event store, like, shall we bring something? Shall we build a library that would just show how we like to do it? But again, use it as an example, copy the source code, take ownership, and then decide what you want to do. That's what I did in the book. I just give you a set of small things that help you start, and then you decide how to do that. Even in our framework in ABAX, we have certain things that I don't like, but it's already there, so I have to deal with that. Sometimes I feel an urge like I will just start from scratch because there's too many opinionated things. Everyone who touches the code brings their opinion to that, and you have to live with that. So that's the risk. So yeah, I would say the second part, something like Martin. I mean, Martin is an event store on top of Postgres. That's nothing more than that. It doesn't bring you event sourcing as such. You can use like, it's similar to events DB clients, so to say. It just writes events and read events. So maybe they have something more. I'm not really familiar with Martin as such. So last question, I guess, for today is, when you replay the events, do we need to roll back daytime no, there is no need to roll back anything. Basically, when you when you need to replay events, so basically, let's say you have you built a new system, and so we're replaying events. So what does it mean? So basically, you have something that needs to build their own representation of state, not your system. Your system is dealing by reading this and rehydrating aggregates all the time. They don't need to replay anything. You have another system that wants to run an analysis, or you have a read model. You have a read model that's, for example, you want to build a new read model, so what do you do? Every read model is like a subscription. If you ever deal with Kafka, you have a consumer group. Consumer group has its own offset, and it moves, right? You bring a new consumer group, it starts from scratch. You tell it where to start. You can start from today, you can start from beginning of times and stuff like that. That's the same. If you want to build a new read model that will just start and reprocess all the events, you start from zero. You start from beginning of times and replay all the events. So there is no concept of clock involved as such. So in some systems like in Pulsar, you can subscribe 24 hours before. That is possible. I think in Event Hub and maybe in Kafka, it's also possible. In Advanced StoreDB, for example, you can just give it a position back in time. You need to figure out where you want to start and you replay. So it's not about time, shifting clocks and stuff like that. It doesn't apply. All right. So there is something in the chat, back to the topic, but what the issue to use integration events versus domain events is possible. Yes, we'll have to deal with. It's basically my point is very clear, and I try to explain it. I will try to summarize it. So domain events is your domain model. Your domain model is in your hands. You iterate, you elaborate, you get new insights, you develop it, you introduce new events, not necessarily new versions. You might just end up having a completely different model. You might need to execute a migration. You just say, I dropped all these things, I convert them to a completely different set of events. So if you use it as integration events, where all these people listening to your changes will end up with, they will get a bunch of stuff that's completely unrelated to their business. So, and you will need to support them. If you don't have control who consuming your events, you would need to inform everyone, like, look, I'm doing the migration, so please stop listening to me, and I will give you a new offset where to start listening. I would say that limits your freedom to iterate on the domain model. It basically locks you up in a prison of integration that you start to comply with integration needs rather than iterating your domain model. So that is the biggest risk. Well, the integration events, since they're produced deliberately by you, by converting internals to externals, you have full control. You can just say, okay, I have a bunch of new internal events, domain events, and I will keep producing the same integration events as before by changing the code that produces them. But then you have freedom of iterating on your domain model. Again, you don't have to do it from day one. You might end up doing this using your domain events for integration for years. It's just that there will be a moment in time that you would say, I need to do it now. That's the only thing. So I'm not saying that you can't do it. Definitely you can. So, right. We haven't even started talking about CQRS and read models. Maybe we should do it next time. But that's basically how I break things. So first is introduction to event sourcing. I see that people are familiar with the pattern and they ask Jason questions. So, I guess if we start talking about read models, we will end up talking about consistency and things like that. So maybe we need to have another event just about this.
Actors, right?
Actors.
Who knows?
Yeah.
Who knows?
Yeah.
Yeah, it's been really good. Yeah, I would like next time. Yeah, probably next time it will be virtual, probably, but I don't know. I would like to, that you come to Barcelona next year,
I'd like
probably.
that too. I'd like that
too. in your winter, you know.
Oh yeah.
Your winter is good because we have summer almost here still.
Yeah, I remember we met when we met. It was
Yeah.
end of September or no,
In
beginning of
Sitges,
September. Yeah, it was
the
very
conference.
hot. Yes. So yeah, I'd love to. So I hope this will be, but they say 2022. So we'll see.
And what about the DDD conference? It's gonna be done or the Europe or
Yeah, it will be virtual event with workshops or
visual?
with
Okay.
hands-on sessions. So we agree that I will do the workshop before the conference. So I think it will be 2 days. I haven't started. I mean, we agree that it will be done, but I need still to discuss the details. But it won't be part of the conference. It's actually a pre-conf workshop like last year.
And I heard you have another workshop, right? Soon about modeling, event storming, or event modeling, right?
Oh, it's not a workshop. It's not me. It's Adam doing the gigantic workshop about everything. I just take a slot. So there will be a talk. I need to record it, and there will be Q&A afterwards. So that's the thing.
I know some people that are going to the workshop.
Yeah, well, we'll be a bunch of people from Event Store. I think there will be 4, including me. So Chris, Greg, and James Gill, and me.
Okay.
So,
Very
but
cool.
it's 3 days, I think. So it's quite a lot of information. I will be talking about DDD. I won't be talking about event sourcing. That's for Greg.
Okay. Okay,
Yeah.
so yes, thank you very much. It's been great. Thank you for your time, and yeah, I
Yeah.
hope see you.
Thanks, everyone.
Yeah, so we will upload the we'll
Yeah.
upload the talk, and yeah, we would like to have you again for sure. You know, with more hardcore topics. People like hardcore stuff, right? But yeah.
Oh, yeah, yeah. I mean, we can definitely talk about reporting and read models. And because someone asked me a question during one of the webinars, isn't event sourcing very bad for reporting? I said, dude, it's the other way around. It's awesome for reporting. And the case we deal with now in ABAX, it's the classic example how a lot of reporting problems, slow performance of reports, overwhelming queries, useless widgets on a dashboard that can destroy your database in no time. And the risk with that is basically someone deploys a dashboard with a widget that queries database 1 year back in time every time you open a page, and in no time you get your whole system down. That happens.
Yeah, I know.
I know.
Yeah.
So it's like, what will happen with event sourcing? I would put a read model that would aggregate this data, and because nobody cares if it's actually real time, it's always consistent in terms of it doesn't show you incorrect data. It might be a bit stale. Problem just disappears.
Yeah, the read
So
models probably it's I will say the huge benefit, the consequence of event sources, right?
yeah,
That
yeah,
you get.
yeah. So people say that there is a bunch of things that related to necessity of read models for UI and for reporting. And the complexity involved. They say the benefit always this by 2 orders of magnitude. It's just so, it opens you so many opportunities. So I'd really love to talk about it next time. So yeah.
Okay, so
Yeah.
see you and thank you, and yeah, so have a great evening to everyone. See you soon.
Yeah. All right.
Bye bye.
Cheers. Bye bye.
Cheers. Bye.